Oxidizing and reducing agents are both reagents. They both are chemicals that exist on the reagent reaction side of the chemical equation. It's next useful to focus on the word agent. An agent is something that causes something to happen. And finally, we can focus on what it is that the reagent causes. An oxidizing agent causes oxidation. A reducing agent causes reduction. We can recognize the oxidizing and reducing agent by focusing on what happens to the reagent in the reaction. The oxidizing agent is a reagent that causes oxidation. It does this by accepting electrons. If something else is oxidized, it's giving up electrons. Giving the electrons someplace to go is going to facilitate that oxidation. So an oxidizing agent is something that causes oxidation by allowing itself to accept electrons. Let's consider an example. A towel is often used as a drying agent. You take a shower in the morning, you grab your towel to dry yourself off. To serve as this drying agent, it accepts water. So it accepts water off your body, and once you use it, the towel becomes damp. It becomes damp while allowing itself to serve as a drying agent and accepting the water. Let's look at a chemical example. Here's a redox reaction. We see copper 2 plus is being reduced down to copper 0. It is accepting 2 electrons to go from 2 plus down to 0. The 2 electrons are coming from zinc is being oxidized. So zinc, in order to be oxidized, has to release 2 electrons. The copper 2 plus is giving those 2 electrons a place to go. So it accepts the 2 electrons and is reduced. So in this reaction, copper 2 plus is the oxidizing agent. Note that when we identify the oxidizing agent, we write the form of the reagent exactly as it appears in our chemical equation. So we're writing copper 2 plus, not simply copper. Let's look at the same redox reaction and identify the reducing agent, the reagent that causes reduction. So if we look here, we see zinc is oxidized from 0 to 2 plus. It does this by releasing 2 electrons. These 2 electrons are accepted by the copper 2 plus, and the copper 2 plus is reduced from 2 plus down to 0. So zinc is the reducing agent in this reaction because it's released electrons that can be used in a reduction reaction. So zinc is identified as a reducing reagent in this reaction. So we're going to practice. We're going to identify the oxidizing and reducing reagent in a number of redox reactions. Remember, the oxidizing agent is a reagent that contains an element that's reduced. A reducing agent is a reagent that contains an element that is oxidized. We start by assigning oxidation numbers to all the elements that are changing oxidation number. I'm not going to take time to go through determining how we assign these numbers. See the prior problem-solving videos if you're having trouble with that. We see here that the element cerium has been reduced from +4 down to +3. It's done that by accepting an electron and therefore assisting the oxidation of the zinc. So cerium +4 is the oxidizing agent. Zinc is oxidized. In this oxidation, it releases electrons that can be used in a reduction reaction. Therefore, zinc is the reducing agent. Note that in each case, when we identify the oxidizing and reducing agent, we express the reagent exactly as it appears on the reaction side of the equation. And we follow the same process for the next two redox reactions. Fe2 plus is oxidized, plus 2 to plus 3, so Fe2 plus is the reducing agent. Silver is reduced, plus 1 down to 0, so silver plus is the oxidizing agent. In the last reaction, H2 goes from 0 up to plus 1, therefore that's an oxidation. H2 is the reducing agent. Carbon is reduced 0 to minus 4. So carbon is the oxidizing agent. These three examples are a bit trickier because it's not immediately obvious which elements are changing oxidation number. However, the more redox problems that you do, the more quickly you're going to be able to identify elements that are changing oxidation number. All right, I've assigned oxidation numbers to all the elements that are changing, and now we can quickly identify the oxidizing and reducing agents. And we can finish off these problems. Note that in each case, when we're identifying the oxidizing or reducing agent, we write the formula exactly as it appears in the reactants.